Among the sampling considerations that we want you to take home, it is very important to keep in mind that take subsamples from a specific lot. That lot could be one truck, could be several trucks, could be one shuttle car, could be several shuttle cars, it could be one hole of a vessel, it could be several holes of the storage in a vessel. But what is important is once you take those subsamples to mix them to have a composite or representative sample. The minimum size for that composite and representative sample should be of at least 2 kilos, which is somewhere around 5 pounds, and use always containers that are clean to avoid any type of cross contamination when you're moving or storing those samples. Always at the end, keep half of that sample as an archive in case you have to reanalyze it a little bit later on. Here in this slide, we pretty much summarize how the whole process of receiving sampling and analysis will take place. You have a lot. It could be many type of lots like we talked a little bit earlier on. You take different subsamples and then mix them together to create that representative and composite sample of at least 2 kilos. Then you divide that sample in two, keep one for analysis, one for storage in the archives. You prepare that sample in order to do the different type of analysis, and then you document those results of the analysis in order to know what is the quality of that overall feed ingredient that you receive from that lot. We always have the question is, if we take subsamples from a specific lot, how do we prepare that composite sample? Well, in reality, there's no really official procedure or science behind it that we're aware of, but we have different recommendations that we could suggest in order for you to take those subsamples, mix them to create that composite and representative sample. Among them are to put the subsamples in 5-gallon buckets, like there are somewhere around 5 kilograms of size of weight. Mix the collected subsamples in that bucket or in a tarp, then divide it to the right size of that sample or cut sample in order for analysis. Here's a diagram of the representation and how to create composite samples when you're talking about a lot that counts several trucks. Keep in mind that we've been mentioning that a lot could be one truck or several trucks. In this case, you could see that we have 3 trucks. In each of them, we took 5 subsamples. Then we put those 5 subsamples in buckets. Then those 3 buckets that result from representing each truck are mixed together and then created one whole bucket, okay, that represents those 3 trucks. Then for working and analyzing that sample, we need to take cut samples or divide that samples into smaller quantities in an objective way in order to be represented, or that whole lot in this case was 3 trucks. So to divide those samples, the composite sample, into smaller quantities for getting to the right size for analysis, for grain we use what is called a Borner divider that you could see here on the pictures of the slide. For products that are more mash type, like soybean meal, DDGs, or finished feed product, use what we call a riffle. Keep in mind that this type of equipment, the riffle and the grain Borner divider, will have different type of channels that are designed to divide a sample into 2 subsizes or halves that are equal in weight. They're doing it in an objective way, and that's where we're looking. Because if you do it by hand, by putting that sample on a table and divide it yourself, then you're starting to introduce the human error, and then it will become a little bit more subjective. So this type of equipment is essential in order to divide samples into smaller quantities that are correct for doing the different type of analysis they need to do to quantify quality. For feed ingredients that have a little bit more fiber content, like wheat, meat, leans, or any type of pasture like hay grass, there's not really any equipment that could help divide that sample into smaller equal size quantities. So in those cases, we do what is the manual procedure, that you lay out in a plastic tarp or a clean surface circle of the product having a constant depth or height of that circle. Then you divide it in sections. You divide that circle in 4, like cutting like a pizza, and then you take 2 of them away and you keep the 2 that are left, you mix them back again, and so on. You make circles with what is left all the way until you get to the right size of half sample that you need for doing that type of analysis that you're doing. So after we get that sample to the smaller size that we need for analysis, there's different type of quality analysis you could do. That will depend a lot on the feed ingredient. Very common to see moisture content, also different type of grading standards, depending if you have your own or you use the US ones. Also mycotoxins for grain, and different also chemical composition that is more related to the nutritional analysis. All those different parameters later will be taught on a different lecture. But what is important to know is that in terms of receiving and sampling, you need to get to the right size of sample that fits this type of equipment in order to have the right size for analysis. And after doing any type of analysis, it's very important to document the results related to the number of samples or the sample lot. This is very important by keeping tags on that sample or putting some sort of barcode or label so you can identify that sample itself, so we can relate it to the lot that is coming into our feed mill for that specific feed ingredient. To conclude this presentation, it is very important to design receiving systems for a wide variation of ingredients, for example, grains, soybean meal, minerals, liquids. It's very important to have your own quality assurance and control program that can help you check the quality of any feed ingredient that is entering your facility before it's being unloaded. You need to have your own sampling scheme based on your conditions that you have in your facility and the logistics that you have, and also based on the type of ingredient. And also keep dust control systems in your loading or receiving area to reduce the waste of product and also contamination to the environment. This concludes the lecture of receiving and sampling of feed ingredients. Please continue with the corresponding quiz. Thank you very much for your attention. Again, my name is Carlos Campabadal. I work as an outreach specialist in feed manufacturing, grain storage, and faculty at the IGP Institute of the Department of Grain Science and Industry. My email, you could read it there on the slide, and also my phone number. I'm also can ask her any questions when you need it. Thank you very much.